All right, how's everybody doing tonight? Doing okay? All right. Everybody got the pen in already? I'm going to write up on board. It's a 1. All right. I put up on the board some final weeks, which we are approaching. Tonight, we're after the discussion on the chapter content. We're going to be you're going to be doing a take-home for subnet exercising on converting binary to decimal and decimal to binary. You'll actually have a week to finish all these the subnet exercise. Next week, troubleshooting lab. That one's where you get the opportunity to become you're a troubleshooter, and also you're the end user with the problem. And the end user problems range from mood swings to network connectivity to broken English to you can't follow directions to you've just been fired from a networking position and you think the current network admin is useless. So just to name a few. And you as the troubleshooter need to figure out what the problem is with the clues that they give you. So that's a fun one. And then week 12 is slated to work on your final paper and presentation. No face-to-face class that night. So wrapping it up, or maybe for some of you just starting to work on it. But use that time definitely. You can come here on campus like you normally would and work down in the lab or at home in a quiet place to get your work done. We went over the outline help, I believe, a few weeks back, and so hopefully you should be good to go on that. And then weeks 13, when you come back, we're going to do a lab on creating users in Windows, Linux, and Mac server environment and showing you how to do that. And then weeks 14 and 15 is final presentations. And I believe it's A through N or something like that in week 14 and the rest in week 15. On week 15, I'll be bringing in pizza, and then you guys can bring in other stuff, pop and chips and whatever else you want to bring, and we'll do that. Also, we'll do on the last session, after all the presentations have completed, we'll do a tour of the IT lab of from the brain center of the lab all the way to all the server room and switches, voice over IP. And so that'll be the last thing we do. Now the week after week 15, which is week 16, is actually slated on the college every semester for your actual finals for all your classes. But since we're doing your final on weeks 14 and 15, for your that is your final, is your presentation and paper, you will not need to be here on week 16. Now, a note on the papers are not due, the research papers are not due till the night of your presentation, all right, whenever you give your presentation. As far as order of presentation, it's whoever wants to go first on weeks 14 and 15, depending on what your last name falls in. And 10 minutes minimum or maximum on presentation length, which is not a lot of time, and so you should be able to fly through that pretty quick. Just a word of help. Make sure your presentation is not a word for word of your research paper. Just make sure it's like an outline view format. You can use note cards if you want to. I always tell students to time yourself prior to the presentation because you'll be surprised how much data you have to present, and 10 minutes will go by really fast. I'll generally give you like a 2-minute warning in the back and to let you know you're near the end. And all the presentations will be recorded. And then the PowerPoints will also be put in each week's folder for weeks 14 and 15 to where you guys can view each other's PowerPoint and presentations as well. Okay? Any questions between here and week 15? All right. Well, let's go ahead. Yeah, question.
Earlier in one of my other classes,
Yep.
you said something about
Well, next Friday is Good Friday, I believe. Let me look here real quick. Yeah, let me look here real quick. I've not heard of that. Yeah, that's right. Let me see here. I think you're right. Yes, teacher training that day. You're right. Let me see if we're having evening classes. Because it's during the day. It'll just double check. You're probably correct on that. Yes, we do have day training. I forgot. Next Thursday. Yep, correctamundo. So let's do this then, if that's the case. Let's see, trouble. Yeah, I'm going to have to bump that up. You're not going to get your day off for working on the presentation. So we'll bump everything up on the schedule since we're not going to be here next week, which is actually week 11. We'll bump troubleshooting to week 12. And so this week's going to be knocked out. Thank you for mentioning that. I thought it was I thought evenings we had open next week. So, all right. So next week, no class next week. Get to work on your presentation final next week. Thanks for bringing that up, by the way.
So just in clarity, so it'll be weeks 15 and 16 when we're presenting?
No, so weeks 14 and 15. Yeah, week 16 is actually slated on the campus for finals. Yeah, and it's a wacky schedule that week. Week 16 is. Yep.
Does that mean also that we use it all night that we don't have classes then, so like we should be in class?
Yeah, all of Thursday.
Okay.
Yeah, thank you for mentioning that, because last spring we did have our evening classes, even though we had our training during the day. So, all right. Thanks for telling us. Appreciate it. All right. So let's go ahead and go to the week 10 review questions, quiz, and the take-home is going to be due. Technically, I have a week to work on all of that. And let's jump right into the chapter content, which is on NOS, Network Operating Systems. The most popular network operating system would definitely be Windows. We'll talk about Windows, we'll talk about Linux, and then also file structure in both, and some of the requirements for those network operating systems, some of the differences. So basically, the network operating system architecture is based on a client-server architecture. You've got your server for authentication, file storage, mainly, rules for folder structure, security of what applications users can run on a server or what files they can access on a server. It manages shared resources, and also has some built-in protocols for customization like Active Directory you might have heard of. In fact, here on campus we do have a course on Active Directory which teaches you how to set up Active Directory to where you can set up rules per group of a network to determine what rights they have and privileges they have on your network, from what applications they can run to what folders they can see or can't see, and just to name a few items that can be customized. There are minimum requirements, just like in network operating systems, have minimum requirements just like your clients do for Windows 7, Windows Vista. The minimal server hardware requirements, some questions you ask when you're going through server purchasing for hardware would be, what type of applications are you going to run on that server besides the NOS itself? You might have, like, say, for instance, SharePoint is an example of an application you could run on a server. SharePoint's, if you're going to run SharePoint, you're going to need multiple servers, because with SharePoint you have to have a separate SQL server running on a separate server, SharePoint itself running on a server, and then a third server for administration of SharePoint. So 3 server hardwares just for SharePoint alone. That's a recommendation anyway. So what software? Also, how many clients are going to connect? For the most part, most of these software packages have unlimited site licenses. It's pretty expensive, but that's mainly what most businesses go to if you have over 100, 125 users. But you can buy per seat license as well. But that's something you have to ask. How much storage space will every user need? During the setup process of user accounts within Active Directory, you can give them allotted space, everything from 1 meg to a terabyte of space to unlimited. And that would determine hard drives that you're going to purchase, how many hard drives you're going to purchase, or maybe external storage. Just to mention external storage, Drobo, drobo.com. It's a great storage device that I recommend looking into for businesses. It's fairly low cost, even consumers can purchase. They have like low cost consumer products, drobo.com. Have RAID format hard drives. Basically what that means is on a Drobo device, you can have up to 2 hard drives fail out of 5 and you're still up and going. And basically you plug and play the hard drives and everything works. And it's proprietary technology that Drobo has itself. So if you need a lot of storage space, like terabytes, or you're into media, which media generally needs a lot of storage space. How much downtime is acceptable in your organization when you're upgrading to a new network operating system? There is going to be downtime, and you need to determine what that is. And then what can your organization afford? That might be the first question versus the last question. All right, but operating systems, network operating systems are really they're not the cheapest part, but they're one of the cheaper parts or components of a server that you'll purchase. And we'll talk a little bit tonight about other operating systems that do not cost anything to install, and some of the upsides of that and some of the downsides of that. So with server hardware, you want to look at types of applications, what kind of processing burdens is it going to have on that server, especially if the application is running off of the server itself. Read comments from other blogs and resources about that application vendor, from other IT professionals on their experience with Cerberus, their experience with technical installation requirements, because the company will give you a flowery look at how to install it and all the positives of this application. They're not going to say, oh, and by the way, you might be down for 3 weeks instead of 2 days, because if you don't have this, this, and this, you're going to have to order it, and by the way, they're back ordered for 5 weeks now. They're not going to tell you stuff like that. They're going to give you a nice presentation on what the positives are of the application, whatever that application might be. So the best way to give reputation requirements is just search for it. That spiceworks.com website that I showed you this semester is a great resource. Technical Republic is a good resource. And just Google the name of the application itself, and you'll get vendor replies or customer replies of that vendor. And, you know, most reviews you read online that are professional, even magazines and, you know, networking, security companies could be biased towards that software. And so it's better in my mind to have people that are using it that are in no way tied to that company whatsoever or that vendor whatsoever. Does that make sense? So reading reviews is definitely going to help. Now on the server itself, the way that I look at cost is about a 5-year plan, looking down the road 5 years on how much the company's going to grow, maybe new employees, new software, new technology. Because if you don't plan 5 years, you can really shoot yourself in the foot as far as cost goes. Because that's a fairly good time frame that servers last, 3 to 5 years on the time frame. So you want to make sure and keep that into your equation for cost. So here's some client support information about network operating systems. They do allow, as we already mentioned, resource sharing, but the task that network operating systems help clients with is creating and managing client accounts, because not only can you create user accounts, but you can create client accounts per computer. And those computers can be added to the Active Directory component within Windows Server. You can enable accounts to connect to the network or not to connect to the network. You can allow clients to share resources, manage shared resources, facilitate communication between clients, all within a network operating system environment. You know the first bullet point here, login process. When you log in through your client, it authenticates on the server and then allows that user, that client, to access file structure, server location, components that server gives the user. So here we have a file server, we have multiple clients, and there is what's called a client redirector. And the client redirector basically just redirects the traffic for the login accordingly, whether it be a failed login attempt, whether it be giving it to other resources that it needs to go to. So say they log into a server and that client that logs in is only supposed to have access to 3 other servers in your organization, and that's it. It can redirect to that and connect them to those services. It could be web services as well that it's connected to. There's a lot of web services today. Now the term in client-server architecture you'll hear a lot in networking is called middleware. Basically all middleware is anything in between the server and the client. Anything meaning hardware. So you're talking switches, routers, hubs, stuff like that. It could be also access points, middleware. Anything in between the server and the client for communication purposes is middleware. Okay? A lot of companies like Cisco deal mainly in middleware for voice over IP, access points for wireless, switches and routers. And 3-tier architecture is basically client-server environment incorporating middleware. So you've got basically your server, your clients, and then in between is the middleware. Everything that connects in between there. And that could be, like I said, routers, switches, hubs, trying to think of what else, mobile devices possibly for connectivity purposes. So pretty simple on that as far as middleware goes. Now, one of the things that this screen really highlights well is there is multiple clients today that you have to work with, probably unlike any other day in networking. Used to, it was either you had all Windows environment, you had all Mac environments, you had all Linux environment. Now you have a conglomerate of Windows, Mac, mobile, and the mobile would be, Apple, Droid, just to name a couple of the top higher type of devices that are used. So not today, not only are clients considered to be PCs like pictured here, but what else are clients today besides PCs and desktops and laptops? Yeah, phones would definitely be all right. What else? Tablets. I mean, that's huge. In fact, Windows 8 that just come out, the beta, somebody was showing me in here. Who was it that had the beta release of 8? Okay, yeah. It's targeted more towards mobile devices. And that the operating system itself is actually targeted, it will install on laptops and desktops, but as far as the look and feel of Windows 8, it's actually really, to me anyway, looks like it's targeted more towards a mobile touchscreen type of platform. And so a lot of companies are going that way, and so that's also part of the clients now. And then middleware is basically just a connectivity. Now, one of the things that the book doesn't mention, but I'm going to mention it here, is I think of this term here as middleware today. Cloud. Any cloud technology could also be considered as middleware. Okay? Tons of that stuff out there right now, from Microsoft to Cisco, Google, Netflix. I mean, you can just think of media, any media type of enterprise that's out there today for people, consumers to download or to stream is via the cloud. And it's middleware. It's in between the client and server architecture. And then server is still around in corporate environments, but a lot of consumer or smaller businesses you'll see start going away, especially smaller businesses, probably going away from multiple servers, because you can purchase a lot of the stuff on the cloud, basically. There's even cloud services out there now where you can actually authenticate to, from a business standpoint, get applications from, data storage, client resources, all found upon a cloud technology. Salesforce.com is probably the number one entity business-wise I can think of that's really utilizing the cloud heavily. They're like the number one provider for cloud technology right now. And they are on the bleeding edge of how it can be used, probably. And so a lot of businesses are using cloud. Look to Salesforce.com to kind of the way to do it, all right? Because they were probably the beginning grassroots company that started using the cloud a lot. So basically, after the client authentication occurs, users then begin getting access. And on week 13, when we do the creating user accounts, one of the things you do when you create a user account is you give them privileges to whatever they need. And usually it's called like least privileges to what content that they need on the network, resources, printers, other file servers, things of that nature. So usernames inside of a network operating system, specifically Active Directory for Windows. In Linux, it's groups and users. In Macs, it's kind of groups and users too, is what they call it. And basically that's what it is. It's setting up users per group. And so you've got basically a group for HR, you've got a group maybe for sales, you've got a group maybe for, let's say, developers. Each one of these groups is going to have multiple users in those groups. But the way it's set up in a network environment is each group will have a set of rules that each group has attached to it, and then you just add those users to those groups, and they now become a part of those rules. And the parent is the group that they're dumped in. And so if a group moves from, say, HR to sales, you just move the user over. You don't have to worry about rights. It's already encumbered or enveloped with the group itself. And so it really helps manage that security easily by using a group kind of architecture within user creation on network operating systems. So an example gives here different groups like teachers, students, administrators. Say the teachers have read and modify rights to programs, full control to grades, and no access to staff. Students have read to programs, no access to grades, and no access to staff. Administrators have no access to programs, read and modify to grades, and full control to staff. Okay? And so again, each group having certain rights that can be changed dynamically. Once you change them within a group, everyone that's in that group then has those rights or privileges modified and changed. Next is what's called basically within this same area, nested rights, which can get kind of confusing, but you can have actual, within a group, subgroups, which can get real confusing. Whenever you set up networks, you want to kind of steer away from that as much as possible, because subgroups can have rights in and of themselves that are separate from the parent group. But one of the things that's kind of confusing with that is the subgroup cannot have greater rights than the parent group. It can have less rights, but not greater rights. And so what I always tell students is, with Active Directory, which is what you'll be using the most of in this environment, steer clear of any type of subgroups within a network operating system. You want to kind of subdivide your groups on a linear level, just one level of groups. Does that make sense? As much as possible, because you can get pretty hairy in permissions and pretty crazy on figuring out, okay, what's the parent group right? I just had a discussion with a network admin last week about this. He was working with SharePoint and and we had a 30-minute discussion on restrictions and rights, moving from a parent group to a child group within that parent group. And we figured it out, but it is confusing when you have nested groups within a group. Now, modern network operating systems basically have common elements. One would be users, printers, servers, data files, and applications, regardless what the network operating system is. Mac, Linux, Windows. All these are going to have these components. Also, each one of these will have some type of directory system. This directory system will have some type of order and hierarchy and security to it, like, say, Windows, NTFS file system, okay? Macintosh, Unix system, Linux, Unix system, all right? Your Droid devices, Droid phones are more on the Unix side as well, as far as file structure goes. And so, but all of these are going to have file system directories and structures that have to talk to each other. The next is the word LDAP, Lightweight Directory Access Protocol. This is just a fancy term to let users into what they need to get into for authentication purposes. Like when you log in here on campus to Eagle, to online services, to your Gmail account, you're using LDAP, okay? When you log in, it allows you to authenticate, and then it puts you in groups of that authentication. And it lets you have rights to whatever services you've logged into. Has directory structure, and you have certain attributes like username, password. After you log in, where do you go? What do you have access to? Things of that nature. Okay. It's kind of like you can think of it as a spreadsheet. LDAP is, and when you log in, you have columns and rows, and each column represents certain rights. Each row could represent users. We'll say, user A, B, and C, and then these 1, 2, and 3 columns have to do with rights. So you could have certain users having all rights, certain users having limited rights to that directory, to that file directory, okay? And so LDAP basically can be used in all systems, both web and also computer networks. And you've got basically 2 schemas is what it's called in LDAP. One is classes, and second is attributes. A class would be basically what type of object you are, whether you're a person or an object, like a printer, file, server, switch, router. And then attributes would be the information stored about that object. Like user would be what? What information on a network do you think a network keeps of you, the user? What's some information? Get granular, I guess, here.
Login accounts.
There you go, logging it. But let's get more, I guess, more detail as far as what field names, I guess you would say.
Like, first name, last name.
There you go.
address, things.
Yeah, first name, last name, username, password, things of that nature. What group you're a part of. Yeah, location. Just to name a few of items, attributes of you, a user. So here's a NOS directory, basically. And this is pretty global with all network operating systems, whether it be Windows, Mac, or Linux. The top three: user account, computer, printer, domain. All right? And below, on the schema, this is just breaking down the above into architectural guidelines to where it can be graphed and charted and put into spreadsheet type tables. Now, one of the things every network has is called an organizational unit. Okay? Organizational unit you can think of as folders or groups. It's probably simpler for students to think of as folders maybe. Okay? So basically what you've got is, let me show you here real quick, easy. Okay, so we've got a company here. We're going to call this company a real difficult ABC company. All right? And in this company, they've got multiple divisions. Give me some division names, or departmental names, not divisions, I guess, departmental names of companies you've worked for. Some departmental names in those companies real quick. Just throw them out. HR, there you go. All at once. Let's do it. Payroll.
Finance, service.
I can't spell. We're doing Ray. Warehouse. Marketing. Anybody else? And by the way, Ray is payroll. All right. So basically, you take the names of the groups or the directories, or in this case would be the departments, and they become the OU. They become the containers. Okay. They come the containers. This would be called in what's called the root of the business. Organizational unit is the technical network term. And then basically these here are containers. And containers can have other stuff in them, like a bucket can have stuff in it. Really a better way to look at it is a tree. When a tree, what's the very bottom of a tree, I guess? What's the very first thing in the ground? What is it? The root, right? The root. And so it's kind of reversed. It's this right here, the root, okay? Then what do you have from that? What do you got from the root of the tree? Right, the trunk. And you can think of that as and then branches from that. And so these actually would be this right here, this line right here. You can think of this line as a trunk of the tree. All right. And then this line here right here is a branch, a big branch, and these are sub-branches here. The C's are the sub-branches. Now, can you add other branches to a branch, to a main branch? You can, right? You can have one branch and sub-branches, right? So I could add to this C, I could add another group, and I'm going to call it here users for simplicity. Okay? It's a users group within payroll. Now it's a container. This is still a container. Now I can add, just like a branch, other branches to this, or I can add what's added to a branch besides another branch on a tree. A leaf. Can you go beyond a leaf? No. Same on a network. I can go out to a leaf, which would be a user. A user. Okay? That's a leaf. Another thing that could be a leaf would be a file server. That could be a leaf as well, and it is a leaf. Another leaf would be a printer. Okay? So these are all types of leaves that can be added to a container. And so if you think of a tree, which Novell network operating system, which used to be real popular, isn't so much anymore, actually used the tree name for directory creation or network creation. And it was really, pretty ingenious, and it was easy to gather and understand it. Most network diagrams you see today are kind of like this, though. They're kind of, you got a circle at the top, which is the OU, organizational unit, which is generally a conversion of the company name of some type. All right? So like Microsoft might be MS, whatever. A lot of times there'll be locations of that. So you have, like Microsoft has multiple locations throughout the world. They might have different locations, and the OU becomes the location that they're at. So say Seattle might be an OU. California might be an OU. I don't know, Germany might be an OU. So, that becomes the location. OU becomes the location becomes the OU. And then everything else below here would be the same in every location for the most part. There's a nicer look at what I just drew. Okay? So basically you've got your root, your branches, which are also containers. Then you can have sub-branches, and then finally leaf objects. And again, leaf objects, printer, user, file servers, just to name a few. Okay? Containers are really for organizational purposes on this chart, and they are also, like in Active Directory, would be group names. Okay, group names like marketing, research and development, HR, things of that nature. So before you do any installation of the network operating system or any creation of users and groups, guess what? You're going to have to do something like this. Now, maybe not as nice and neat as that. It could be as crude as that to start with, and then begin from that point, and then begin drawing and erasing and spending a few weeks playing with that till it looks like that. Okay? But basically, you're brainstorming and changing and moving and growing until it's where you need it to be. And a lot of times, well, not a lot of times, I recommend inviting other departmental managers in during that process to determine, do we have this right? Does this look right organizationally? Okay? They could say, well, yeah, marketing and R&D definitely are separate, but we use all the same components. Same printers, same file servers, same resources, so we technically could be one. Okay, I didn't know that. That's why you invite folks that are non-IT to get feedback like that. Now, generally, you would do like a brainstorming within IT only to figure out, okay, this is what we think it is, and then bring people in to basically correct you and make sure, and kind of steer you in the right direction, because they're going to be ones using it. So plan it. This will take, and the future needs too, you can actually put in on the tree itself. Like you could put on the tree over to the right, like maybe another business or building that you're going to be building in the next 5 years. You could put that there along with some of the structures that might be in there. And again, it's just far-reaching, but you'd need that to determine cost. Say in 4 years from now, we're going to be buying servers for that location, and we're going to need to include that then in our budget. Does that make sense? In our forecast budget for installation and training and things of that nature. So again, the dotted line scenario here is generally what you'll see to kind of see, okay, this is what we could see in the future, what's coming in the future. In this case, circuits and transistors. Next is within a NOS system, you can share applications like Quark Express we have here on campus, which is a desktop publishing system. You can log in to Quark Express from any system that's installed on. It'll look to the server for the license for that. I think we have like 30 licenses on that application. Once it reaches 30, if say you log in and you're 31, it'll say you've reached the limit of licensing. You'll have to wait for somebody else to back out, something like that, before you can get in. Well, that's all ran from the server. That application's run from the server, and the licenses are managed from the server. So the whole purpose of running stuff from servers are twofold. One is licensing. The second is cost. It is cheaper to run applications from servers than it is purchasing per client. It is cheaper to do it that way. Especially, in today's, like say, I'll give you an example of Sears. I used to work there, during the summer, and they had thousands of stores nationwide and locations, and all of their applications on all of their retail stores are all stored on servers and run and pushed out to what's called thin clients. Okay, and the thin clients basically just have a dummy terminal, monitor, a little box, keyboard, mouse, and that's it. And that's it. That's all you got. And everything runs from a Cat5 cable back to the server room, and literally all the applications are pushed to the monitor. Okay, sharing applications are much cheaper, more cost-effective for Sears than it would be buying all individual stations and then keeping up on all that, and then worrying about viruses and all that good stuff. They don't have to do that because it's all ran off a thin client type of platform. Because you have costs, which would be per seat license, per user license, or a site license. The one that most companies go with is this bottom one, especially, like I said, if you have over 125 users for most of these applications, I'll recommend that because it's cheaper. But if you have 10 users, it might be cheaper to do a per user license. But say you have 100 users, but only about maybe 10 at a time are using that application. The per seat license would be the one to use then. Okay? Does that make sense? Because you have 10 seats that you can use at any time for that application. And that's it. And then if you, like for instance, we have on Eagle a certain amount of seats that we can use at one time. Now, do we have all the students that we have enrolled purchased? No. I believe it's something like a little over half or something like that. I think that's what it is. And that's not uncommon for businesses to do that as well. If only going to, if not everyone's going to, if you have 3 shifts and each shift has 500 people and maybe only 300 of those people use that application per shift, you only need the per seat license would be much more reasonable for purchasing. Okay? Does that make sense? So shared applications is definitely one of the benefits of network operating systems. On this slide, basically, just want to mention the NOS is responsible for arbitrating the file access, and what this basically is referring to is denoting security on who gets rights to what. The network operating system controls that, and the network administrator administers that. And then finally, print sharing is definitely used within network operating systems to allow users with multiple divisions to share printers. Again, cost effective. So we've got multiple printers here that all these users, basically, if they're connected to the network, can use at any moment notice, can connect to. But now you can give rights to every single printer that only certain users can have access to. I'm not going to go into creation of printers. I will mention on this slide, most of your servers today will have tons of memory you can add to it, and also hard drive space. And an example would be one of the network administrators the other day told me that he had spec'd out a new server that had a total combined 2 terabytes of memory once you put all the processors together that they could have in that system. That's just memory. That's just memory. That's not including hard drive space. Because that's something like 32 processors, quad-core processors, quad-core processors, 32 of them. And then each processor had a max amount of memory you could put into it, and then combine it. If he did buy, which he's not going to, the total amount of memory he could, it was something like 2 terabytes of memory. I mean, that's crazy. But, you know, if you think about it, if you've got, okay, Amazon.com, tons of resources, tons of processing going there. I mean, constantly 24/7. So when we're sleeping here in Rockford, there's another town in the week buying stuff on Amazon continually. And so maximizes server memory because you can add basically with NOSes multiple processors, which you cannot do with a single client. And that's where the benefit of network operating systems come into play, really. You have in NOSes the ability, which you also have this ability in clients, to do virtual memory. But the problem is, or the benefit of NOSes is you have that times how many processors you can add to that server. And virtual memory, the same. But if you have 2 terabytes of memory, you really don't have to worry about much on virtual, for the most part. Okay, you're pretty well set. There are some advantages, though, on virtual memory. Cost, it is easy to expand, but downside to virtual memory is it slows the processing power. It slows the speeds of that network. Hard drive disk space, the read-write arm's going crazy because you're actually using the hard drive as a virtual memory location, okay? So say you take up a gig of hard drive space for virtual memory, it's constantly looking at that gig space for usage at all times, which can, you know, cause downtime as far as connectivity. It can limit it. All right, multitasking is another one that servers help you with. Because servers can be so beefed up in memory and processing power, you can do what we call quantum computing, which is basically taking all these computers together in this room and combining them in as one computer. Does that make sense? All memory power, processing power, all within one. Like I had a student last hour that has a solid state laptop he just purchased, and if you know anything about solid state, there's no read-write arms on that solid state disk. And so he was just showing me, you know, not just, you know, application speed, but browser speed, just browsing the web. He was showing me how just quick it is, just like boom, boom, just because there is no lag time on read-writes on that disk because it's solid state. Because all of your hard drives will have a read-write arm going like this constantly, which can wear, and it does wear on that hard drive, but also can slow down the speed of connectivity. Well, solid state, which is actually coming down in price, has no read-write arm, and so they can access it much quicker. So could you imagine, and actually I've seen videos of this, of servers implementing solid state drives versus read-write drives with ARMs. It's crazy as far as the amount of speed it adds to it. Because I was trying to think, the first, I think it was a year and a half ago when I was pricing solid state drives, I think it was like a 500, no, it was a terabyte. It was a terabyte drive a year and a half ago. It was something like $4,200 for solid state drive for one of the servers. But now, you look at the prices now, they've come down so much now that about a fourth of that price for that type of drive. And they'll keep coming down because of the consumer demand. Do what?
Completely better than solid state.
In some situations, I've heard it's not. Like for instance, it would be overkill in some situations. That makes sense? It'd be overkill. You wouldn't need it for, like, if your environment only does office documents and say maybe Access database, and that's it, you wouldn't need it. It'd be overkill. But say your environment does media. It's great for media. What I mean by that is if you're pushing stuff from your client to your server that's media-based, that's where you get the benefit of solid state. Okay, does that make sense? Because the speed's going to be there, Streaming, it's great for streaming because speed is going to be increased because you're not going to have that read-write lag for the drives. So, yeah, exactly. Wear and tear and power consumption, heat. Yeah, heat too, right? Yeah, heat. Heat would be another one. Less heat, so meaning less amount of fans needed to cool the device because you're not going to have the heat from the arms of the hard drive. So,
I got one of those thin clients. I'm using it to run a Mac. It's an older style Mac.
oh yeah, yeah.
Man, I can't even tell that thing on. It
Oh, yeah.
doesn't have no heat.
Right.
And I can't even tell it's on half the time.
Yep. Yeah.
And I
Yeah,
just
because
wonder why they didn't
it's
do
kind of
that.
like an electric car at a stoplight. Okay. You take off, you're like, okay, where's it at? You hear nothing because it's electric, right? It's powered by electric.
Why didn't they? I guess I don't understand how come more computers aren't, solid state.
Cost. That's it. But like everything though, right? Eventually you'll see more and more and more solid state come in because the higher demand for it, the lower the cost will come. So the more people buy it, the more companies buy it. And granted, the cost, yeah, the cost has come down quite a bit in the last year and a half. It'll keep coming down. So, well, that goes without saying with the regular hard drives, read-write hard drive disks. It's the same, but it is less expensive, so it's more disposable. You're right. So. It started out with, years ago, Apple had, I think, the Mac Air it came out with, but now you've got a lot of Windows laptops coming out with solid state hardware that's fairly reasonable, and tablets, same deal, fairly reasonable. All right, I know you guys are getting ready to go to sleep, so I'm going to see if I can expand here. I'm going to go a little quicker here. I'm going to jump right to 2008. Server, which, has anybody taken the server or signed up for the server class here? Okay. Just finished, okay. I definitely recommend it. It's fast-paced, but it's a good class. And if you're going to be going to networking as an administrator, it's great. You need to do it. And it's definitely cheaper taking it here than it would be anywhere else for sure. But there's different editions, just like in all Windows. There's different editions of server NOSes. You got standard, web, enterprise, data center, and each one of these will have in the description what it fits. I always tell students you want to go one up. So say you're looking for something for a website, go to the enterprise because you might need more power than what you think or more tools than what you think. If you need just enterprise for business authentication, and that's it, go to the data center. Does that make sense? So always go one up, because you don't want to be caught after you've paid for it and realize, oh, I needed this. All right. So always go one up from where you think you need it. Popular NOSes today, I've already mentioned, but Windows is number one. Right behind it would be Linux, and then Macs are server. The big one Mac's pushing now is a Mac Minis for their servers, because Macs used to have what's called an Xserve that they end of life was, I believe, November of last year for that. And Steve Jobs wanted to get out of the server business, the hardware server business, but they still have the network operating system for Apple. And I believe University of Madison, Wisconsin uses pretty much all their servers are Mac-based. But Windows for business is definitely number one. Number two, for websites, Linux would be number one as far as servers go. Media and media warehouses, it's a mixture of Windows and Mac environments. You'll see those two. You might have like a lot of Mac servers for streaming media, which it works well in, and then the Windows more is developed and really works well in an office environment for office docs and things of that nature. SharePoint's a great tool, which is an office type of application from Microsoft. And then Linux, more the open source consortium, which I told you I'd talk about earlier. I'll end on this one a little bit. Linux, we played a little bit with, but Linux basically is totally free by design. It's open source, and you can basically set up a whole network with Linux from server to client. And the downside is there's so much documentation out there that it can be confusing going into it. I've set up a few, like 4 or 5 networks on Linux, and each one of them is different. And they, but a lot of them are educational facilities because the schools can't afford to buy Windows 2000, Server 2008, and so they maybe install Red Hat as their server, which is a popular one. Another popular, Novell I talked about earlier. Novell now has SUSE Linux, which they actually install it and will support it, and that's how they make money now. Novell does, through supporting SUSE Linux, which is a great platform for server network operating system. But any Linux server I'm talking about, like SUSE, S-U-S-E, Red Hat, those can be downloaded from the web at no cost. You can install them and play with them. Most of them have what's called a live preview that you can play with and see what you want before you install it. And they, like, for instance, SUSE downloads into about a 4 gig, enough to pretty much fill a 4.3 gigs on a DVD, fill that up, and then you can install it from that on a server. The great thing about Linux is, though, that I've seen over the years, is once you install Linux, like say for a web server, which I've done a lot, once you install it and set it up, you can unplug the mouse and keyboard, put it in a corner, you're done. It's over. There's no any type of antivirus software. I've never installed antivirus software on any Linux server, ever. Never had to. And they just run. And the reason for that is, those of you maybe take Unix or you've played a little bit with Linux, the file system for Unix or Linux is totally separate than Windows. Now, Windows 7 is about as close to Linux as you can get without being Linux. The reason for that is every user on Linux is basically its own separate operating system. When you install a new user on Linux and you log in as that user, you're totally separate from everybody else, totally. You can't even see everybody else, okay? The only person that can see everybody else is what's called the root user in Linux. Now in Windows, when you put multiple users in there, you can go into My Documents and see everybody's folder, right? And see when you click on it, a lot of times you maybe can't get into it, but you can see it. And you kind of coexist right beside each other. So if I'm a client, I'm a user on your computer in Windows, and I get a virus, well, you also get the virus, right? If I'm a user on Windows and I log in, and I mess up some system file in C Windows directory, guess what? It's going to also mess up your session when you log in. Linux, the way it works is, when you create a user, and say you have 100 applications on that system, when it creates the user, every time the user logs in, it's basically like taking a virtual copy of every application and storing it in a whole session just for that user, and that's it. And so every single user has basically, like I said, their own separate operating system. And as far as security goes, because it's totally separate like that, even if a virus was to hit a Linux system, it would only affect that one user that was logged in at the time that virus was installed. It wouldn't affect everybody else. That's how it's designed. Now, Windows 7 architecture, or Windows itself, started changing when the .NET Framework hit. You guys heard of the .NET Framework, right? .NET Framework allows you to install applications in any folder. You can just take an executable, throw it in a folder that's developed by a .NET Framework software, developer, and it'll run. Before .NET Framework, you had to do what's called register that application in Windows. And you had what's called registry DLL hell is what it was called in development, where basically I would install create a software, you would create a software, and we had conflicts, and maybe yours installed after mine, yours wouldn't install because it conflicted with mine, because everything had to be stored in the same location in the registry. Now Windows still has registry, but .NET Framework does not use registry like it used to use it. In fact, it doesn't use it at all. .NET Framework runs in and of itself outside of Windows, believe it or not. You've got the Windows operating system, then you've got the .NET Framework. So the .NET Framework, you could say, is structured. In fact, Microsoft about 4 or 5 years ago was at Linux World for the first time. They had a booth at Linux World, and it's a yearly conference. Anyway, Microsoft hired tons of Linux developers, okay, to help develop .NET Framework. So the reason I believe Windows 7 is so stable as it is today, and it is a fairly stable platform, is because of the .NET Framework, which, guess what, is based on basically Linux platform OS. And so you've got your Windows still, but you also have the .NET Framework, which is basically a Linux OS within Windows. And what's cool about it is you have seen over the years, especially with Windows 7, less and less, not that you don't still get viruses and malware with 7, but the way it handles them is totally different than what it used to handle, say, in XP. Okay, the way Windows 7 handles things and handles attacks is totally different today than what it was in, say, Windows XP, Service Pack 2 even. So yeah, you can still get them. It's still not perfect, but Windows isn't going anywhere in a business world because everything functioned business-wise in Windows. Linux, again, files. If you look up, most of your web servers today are Linux-based. And the reason for that is what I just mentioned earlier. You set it up, you put it in a corner, and you're done. Okay, you don't have to worry about it. Okay, but as far as a productivity server with Office and sales and things like it's not designed for that. Linux isn't designed for media. It's not designed to create videos and stream videos. Not designed for that. Macs are designed for that. So whatever environment you have, you do have NOSes that kind of fit that environment, if that makes sense. For Windows, for Office environments, Windows fits it well. For web environments, Linux fits well. For media, Macs fit well. Does that make sense? And that's pretty much been the way it is, been for maybe the last 8-10 years. Now I will say, I was a graphic designer for 8 years, and I used to speak in New York every year to a convention for graphic designers. And when I first started talking there, and we'd host like conferences and say you guys are a whole room full of developer or designers for different publishing companies. 10 years ago, I'd say, okay, how many of you guys use Macs? Everybody in the room raise their hand. But like 5 years ago, it started being like about half and half. Half Windows, half Mac. And that, guess what, is when the .NET Framework came in. And it's also when Windows began developing software that was compatible with the software that Mac was using at the time, which would be Illustrator, Quark Express, do what? Yeah, and exactly. Using the Intel chip. And so about 5 years ago, between the .NET Framework, Mac's getting an Intel chip, is when they began to be able to work together. And today, there's a shop here in town that does all graphic design work. It's called Trek Design. You might have heard of downtown Rockford. Anyway, they're all Windows based, and they have all of their applications are, you know, same one Mac uses, you know, Illustrator, Quark Express, but it's all Windows based, and they run fine. So there are instances now where you'll see kind of, you can do either or on media. But if you're a web design company, mostly it's going to be Linux. And then when it comes to web development or it comes to file servers, like we were talking about tonight, network operating systems, take as many classes as you can on network operating systems while you're here on campus. Definitely Windows would be one. I'm looking at offering, I haven't had time to do it, but I'd like to offer a semester, or maybe it would be a split kind of 8-week thing on Linux Mac server. I think that'd be kind of cool. Now, technically, I could do a whole semester easy on Linux, just Linux alone. But I'm thinking for sellability, maybe an 8-week thing would work real. How many would be interested in like a half thing? Half Windows, half Mac, half Linux type thing. And it would be all about server stuff. Setting up server. Do what now? Yeah, it would be 4 credit hours, yeah. It would definitely be 4 credit hours. And so, but the total package would be 4 credits. It'd be like 2 and 2 probably, or something like that. I don't know how they'd work it out. It'd be like a 4 credit hour class for the 16 weeks. So, does that make sense? So I break it up. And so, but yeah, we're actually talking about doing that probably in the spring of 2013 is what I'm looking at. And so I can't do it in the fall. I'd like to, but I can't. But I'd like to do that. And then you'd learn how to set up Mac servers, Linux servers, and manage them, set up users, set up clients, set up web services, all that good stuff. So use QuickTime Media Server, talk to different tablet devices with Macintosh server. And so we're looking at doing that. So I think that would be that's a need, I think, definitely. And not really anything around here that does that. So, okay, well, let's switch gears. I want to talk now on the take-home, if we could. So let me go there real quick. All right, the take-home is on week 10. And I'm just going to show you what you need to do, and then we're going to be done, okay? So let's go to week 10, week 10 lab subnet exercise. And it says download and edit the above Word document, read and look at the examples for the network ID and the IP binary conversion, and then you're going to submit it by next Thursday, or next class period, which actually we won't be here, but submit it by then. Let's see if I can get this open here. Now, if you want, you can type these in, or I've had students that like to print it out, then write it in. Then you can just hand it in. Well, we're not going to be here next week, so I guess I'll bump this up to 2 weeks from tonight, I guess, since we're not going to be here next Thursday. But however you want to do it, you can either hand it in, type it in here using Word, or you can hand write it in, however you want to do it. I'll bump up the due date, though, for 2 weeks from tonight. That way, if you want to do a write it in by hand, you can do that. Okay. So basically what I've done is you've got this page here, which you're going to take an IP address, convert it to what class it is, and then give the network ID and the host ID, which we'll look at in a second how that's done. And then the second page goes over the class information, which we'll go over in just a second. And then the third page is binary conversion, where you convert from decimal to binary. And then the fourth page, which is part 2, is taking a binary IP address, converting it to a decimal. All right? So let's start with the second page first. Every network has a certain class that it's in, and that class is determined by the value of the first octet of that IP address. What I mean by octet is you have 3 numbers, dot 3 numbers, dot 3 numbers, dot 3 numbers in decimal version. The first octet would be those first 3 decimals that you can have available. Now, The network address must be unique to the IP network itself. If you plan on having a direct routed network, like this first bullet says, in public network, the network ID must be unique to the internet, meaning if you're outside of, like say you're hosting a website. This network ID that it's giving you here would actually be given to you by like a Comcast, by a AT&T. It would tell you what that IP address is. It would give it to you. The network ID cannot begin with a 127 number because it's a local loopback address. All bits within a network ID cannot be set to 1. All ones in the network ID are reserved for what's called an IP broadcast address. All bits within the network ID cannot be set to 0. All zeros in a network ID are used to denote a specific host on a local network and will not be routed. It's not routable. So here's the following non-routable address defined by the RFC document 1918. So from 10.0.0.0 through 10.255.255.255, anything within that range would be a Class A. 172.16.0.0 through 172.31.255.255, Class B. 192.168.0.0, most of you use this range for your house, for your wireless router, through this number here, Class C. Now these are non-routable private networks. Okay, what that means is what it says. It's just a private network, not a public network, that you can use within any environment. These are the ranges you can use right here. Okay, but now let's look up at the top here on this graph here, this chart here. So we got Class A, B, and C. If Class A, the W portion, well, you guys got W, X, Y, and Z. W refers to the first octet, X refers to the second octet, Y the third, and Z the fourth. Okay? So if the W portion of the network ID falls in between 1 to 126, it's always a Class A. The host portion of a Class A will be X, Y, and Z. The available networks on a Class A is 126 networks can be available. And then 16,777,214 hosts per network. Class B, 128 through 191. 127 is skipped because of the local loopback reservation. The network ID portion for Class B is W.X, the first two octets. The last two octets are the host portion. Available networks on this are the 16,384. Hosts per network, 65,534. Then Class C, 192 through 223. WXY is the network ID portion. Z is the host ID portion. Over 2 million available networks available, and 256 hosts, or 54 hosts per network. So let me go back to page 1. What you're going to do is determine what this IP address, you're going to look at the IP address first. Okay, what class is it in? You look at the first octet to determine what the class is. In this case, it's 129. 129 is in the B class. Okay? Now, before we go back to page 1, let's note here on B, the network ID portion is W and X, and the Y and Z is a host ID. So, B, the subnet is going to be made up of the first two octets, or the network ID portion. So the first two octets are going to be taken up with 255.255.0.0, and that's just a default subnet for a Class B. The network ID would be the WNX 129.102, and then you just fill in a .0.0 for the Y and Z. Then the host ID is the Y and Z, which is just a 197.23. So let's do this one together. 131, what class is that in? B, right? What would the subnet be? Nope. Subnet. Subnet, I'm just looking for 255, the default subnet. 255.255.0.0. Network ID, right, .0.0, and then the host ID. All right, let's find a different one with a different class here. Let's do the next one, this one here. What class is 199 in? C. Now remember on the network ID portion is W, X, and Y, and Z is the host. So, right, 3 sets of 255, it's class C, 3 sets of 255.0. Then the network ID would be the first 3 octets, .0, and then the host ID would just be 54. Make sense? That's how you do that. Let's look to the third one. The third one, you can use your scientific calculator to do this. Okay, if you have your... Let me fire up here real quick my laptop here. I used to have students do this by hand, but I don't do that anymore. Would you use scientific calculator? All right. Do what now? Yeah, well, it's actually not too hard, but I gave up on doing it 2 semesters ago. All right, here we go. Are you ready? Okay. Now, to start, you start your calculator, and then you need to make sure if your calculator is not already there, you want to switch it from standard to scientific. Okay, in this case, we're going from IP to decimal. So we take the first octet of 215. Okay, we type in 215. It's now decimal. Just click on bin to go to octet, to go to the binary portion. That's what you write in this first portion here. All right. Now, one of the things you'll need to do is on the second portion, this is just a binary only. This is a binary IP address. Every binary octet has to have 8 places. So if it doesn't have 8, you have to add zeros to the end. Okay? Like for instance, this one here only has 7 on 122. So you add under 0 to the end here on the bind. The IP portion will have a dot operator in between it. The binary portion only has a comma. And you bring them in natively as they are. Okay? As they are. So this one here would be it's fulfilled 8 on that one on the 215. Let's look at the 34. 34 has 6, so we need to add how many? 2 zeros to the end. Very good.
Add zeros to the left, right?
You're going to add zeros here to the left. I think I said the right earlier. You have zeros to the left to the beginning of the number. Okay, beginning of the binary portion. Yeah, you have to the beginning of the binary IP address or the binary number, you'll add zeros to the beginning of it. Okay? So this would be on this one, you would add 0, 0, yeah, 0, 0 to the front, 0, 0, 1, and then the rest of it. Okay? And let's see, 211. Right, this is okay, it's got 8. And then 9. It only has 4, so this would be what? How would this be changed?
4 zeros.
Exactly. But now on this first one, guys, this binary portion, bring it in as the calculator gives it to you once you hit the bin, separated by commas. This one, you just add the zeros accordingly to fill 8 bits per byte. Make sense?
Yeah.
Yes. All right. Good. Questions on that? All right. Go to the next one. This one you're going to do the opposite. You're going to type in the binary portion in the calculator and then click on decimal. All right? The first is going to be the decimal by commas. Second is going to be by periods. All right? So to do the conversion here, I'm already on bin. Now you're only going to have 0 and 1 available because that's all you have for binary. 1, 1, 1, 0, 1, 1, 0, decimal. Okay? That's all you got to do. Questions on that? Okay, so I believe it's going to be easier for you to just type them in. Is that okay? And then save it, and then submit it to the Dropbox. And even though it's due by next Thursday, we don't have class next Thursday. And we are going to have class on week 12. I'll just put troubleshooting lab on week 12. Everything else stays the same. Make sense?
On page 2, the C class, is that a typo?
Do I know?
Where it goes 192 through 92?
That is a trick one on purpose. That is a trick one on purpose. There's actually a trick one in there, yes, and I think you already mentioned it. Yes. That is a trick one. All right, any other questions? All right, we're done. Excellent. I guess enjoy next Thursday off. Hey, work on your research paper and presentation. Get it done. How many started working on it already? One person. 2 people. 3 people. How many's thought about it? Anybody thought about it? 1 or 2 of you? Okay, good.
I'll get you this one.
All right.
There, please. Thank you.
Go. I think I'm going to move that up. Well, since we're not meeting that week, I'll just move it all up. Get an extra week for that. Yeah, for everything on week 11, I'm just going to move it to the next week, so don't worry about it. I'll email everybody. Yeah.
Well, I stayed out there. I don't really like that. I stayed out there a little bit, and I'm kind of understanding a little bit. It's weird because I got wins. I ran like all my stuff. It's just a little bit
Okay.
than the units that, you know,
Let's,
Yeah, I think that'd be a pretty popular class.
yeah, I'm working on it. I'd like to really get it by spring. I really would.
I don't think I've ever seen a Mac or a Unix server.
Yeah.
A Linux server, so.
Yeah, I definitely want to do it. I'm pushing for it. I think it's going to happen. So if I can get 9 or 10 students, I think I'll be able to get that easy.
Oh, I don't think
So,
there's a problem with that.
yeah, yeah. All right, man. Appreciate it. Thanks.
all that stuff, then you good, you know.
12.
Before, but until you get all that fixed, you got a lot of little kinks to get out. You know? But once you get them all knocked out, you can get shape. It almost look like it almost look like for free. You know? All right.
These final papers,
Mhm.
are they, I don't know, I'm not sure how to phrase this. Do you want more of the technical details in them, or?
Nope, I
Or
don't.
just-
Content is what I'll look at.
Oh, okay.
So, I mean, it depends on what you're doing your research paper on, I guess.
Well, I was gonna do remote access.
Yeah.
There's only so much I could write technically about that.
Right.
I mean,
Yeah, you know, you're focused, I'm guessing, on the uses, scenarios,
Right.
Things like that.
oh,
Yeah,
okay.
yeah, that's what I would do.
All right,
Yep,
thanks.
yep.
See you in 2 weeks.
See you in 2 weeks.
So we still have chapter 10 quiz and questions due by Thursday.
Yep or do. Yeah, for this week, we're no changes for week 10. But week 11, I'm working on changing all the due dates. So technically next week, I think the network's call lab was technically due. Next week, I'm moving that. So everything's basically going to be, that was for week 11 is going to be actually on week 12 now.
Okay.
So I'm moving all that around,
And everything's
and I'll email
consistent
everybody.
Except for the week 10 that's on Thursday.
Yeah, as soon as I get through changing the dates on the due dates, I'm going to email everybody that for sure on the network call lab that's not due till week 12 actually. So,
I got swamped this week.
yeah. Well, it's going to help then, right?
Yes, it's gonna help a lot.
There you go. Good.
Have a good weekend.
All right, we'll see you. Mm.